Hi, I'm CJ and this is my RC channel. I'm continuing the spoiler build, and I did a couple little things that are counter to the instructions. I'm putting the servo on the opposite side of the center rib. That doesn't really make a positive or negative. It's just the way I wanted to do it. I wanted to have as much slack in this cable as possible, so servo's going to go right there, and the cable's going to go right out through that bottom slot. Also, sorry about shaky cam. I added 2 pieces of 1/64 inch plywood. As you can see, it's extremely thin. It adds almost no measurable weight. The reason is to strengthen up the spoiler. Aside from adding the carbon fiber to add torsional strength, these add strength across the grain here. So the magnet is not trying to flex this thin piece of wood here at the edge. Also, I added this piece to create a runner, because the servo arm basically rubs against the surface of the inner surface of the spoiler. So as this thing rotates, it slides along the surface forward and backward as it goes up and down, and that can eventually wear a groove into the wood. So this makes that a non-issue. Can press against there as firmly as it wants, and it's not going to put an indentation into the plywood, and that also adds a little more structural strength. Instead of mounting the magnet on its side against the wall, I used a piece of 1/4 inch by 1/4 inch balsa stock, cut it to the right size, and then set it up, and then it snaps right on down. And it doesn't have that much more strength than it would if it was on its edge. With the added strength of the plywood, it's going to hold this down tighter, make sure it isn't jittering around. Using those cross braces that I added is going to also, once this is hinged, make it a little more stable. And so now I just need to mount the servo. I may elevate it a little bit. I just kind of tinker a little bit and figure out, how this hinging is going to go, because if this is right at the edge, okay, hinge to the edge here, and as it folds up, I don't want, it's a matter of how close the servo needs to be versus how far. It's got to be pretty much against the spar with this little add-on that they provide. It's a little piece of fiberglass. You'll find that in one of the bags. If you are using the Turnigy 1440A that they recommend for the spoiler, it's going to be it's going to fit just fine onto the plastic. You just I took the 2-sided servo arm and cut one end off a little away, so that it would have some contact on the back side here. It's also fatter than the single arm, so it's less likely to break. And then I just used some cotton thread and wrapped it a handful of times, hit it with some thin CA, and it is a permanent resident. I also put a little thin CA at the edge here, which wicked right in, and so this is nice and solid. I recommend using a servo tester. If you don't have one, just use your receiver. You want to set the end point all the way to one side, to the clockwise direction. I guess it depends on which side you have the servo on. Just by happenstance, having the servo mounted on the left side, the sticker here is pointed up. I don't have to worry about this peeling off if I use glue, because if you ever tried gluing one of these things, the servo will just peel up on you. The sticker isn't as solid as you might think. But I am probably going to glue this one in place. I figure it's low probability of failure, even though it is plastic. It could have an electronic failure, in which case I'll just have to cut out, a chunk of plywood here and, put a new piece in its place. Just do a little carpentry on it. So I am probably not going to mount the servo right at this time because I don't have any hinging on this yet. I'm still trying to decide if I'm going to do monocoque hinge or if I'm going to do a CA hinge. So I'll see how that goes. But this is a little out of order as far as the instructions goes. I just kind of jumped ahead to this because I was working on this anyway, and I kind of wanted to look at placement and things. One of the things I'm kind of curious about is this is basically a gravity slash wind action. When this thing opens, the servo opens up and holds it in place by friction, and when the servo retracts, there's nothing attached to this arm, so this is going to have to just fall back from the resistance of the wind, and then once it gets close, the magnet will catch it and take it the rest of the way and then hold it down. The only downside is if there isn't a lot of wind against it, and or if the hinge is stiff, it may not want to fold down flat on its own. It could potentially run into a situation where you put the spoiler up and you want to put the spoiler back down again, it drops to maybe a 45-degree angle and then kind of hangs there because the wind resistance and gravity are not enough to pull it down, and it's not close enough to the magnet to draw it down from that area. So there's a couple of ideas I've thought about. One of them I saw as a recommendation. This is something I also would have thought to use, which is basically a spring. These are for discus launch gliders, for the rear tail surfaces. And you trim these as needed, and basically it's a torsion spring. Well, I'm not going to go into that. Some older cars use torsion springs. Anyway, basically it's just a metal rod that is anchored at two ends, and you're twisting it. It's like a music wire or spring steel. And this could be used to try to hold this down, and then the servo, it would resist the servo as it is wound open, and then when the servo retracts, it would immediately pull down. Now, when the post that I read that mentioned this, the gentleman, another gentleman pointed out that it's at its weakest when it's close to being closed. So that's why I would use the magnet along with the spring and not just rely on one or the other. The debate that they were discussing was what was the lightest methodology. And this is just ridiculously light. Just slide this forward so you can see this. If I were to add this little spring, 0.11 grams, that's not something worth arguing about if it is going to make a better system. And it's right on the center of gravity, so it's not going to necessitate adding tail weight or nose weight if the plane is already balanced. So I may add this. The only thing I worry about using this is that if I'm using a monocoque hinge or even a tape hinge and I don't have the surface attached on both sides, if you've used monocoque or tape hinges, you know that you usually, like you might do monocoque all the way across here, and then on the other side you might just use a few pieces of monocoque, maybe an inch or two wide, to provide the back side, and you want to have a little bit of a gap so that those two sides of monocoque can actually touch each other, even for a fraction of a millimeter of contact, but that's enough to provide a bond, and that becomes the hinge point. If I'm doing a one-sided hinge where I just have monocoque on top and don't have monocoque on the bottom, which might end up being the case because it's going to be kind of, I could do monocoque on one side and do tape on the other. That might work. It's still going to be hard to get much of a gap going where there's actually going to be contact. The concern being that this could rip the hinge over time, because it does have a decent amount of resistance. It's easy to do with your fingers, but when you're talking about something that is, how much force I'm using at this moment to twist this 90 degrees, if I was applying that same force to peeling up a piece of tape or monocoque, it's right in that range where it would easily peel it up. So the hinge has to be solid. So if I do want to use this, I might need to go with CA hinges, or even just a few of them, and do monocoque on top. Again, trying to figure out what I want to do. The instructions kind of leave some of this stuff to the builder to figure out what works best for you, what you want to do. And that's great, because that's the way building should be, I think. Not everything can be done for you. Anyway, I'm going to continue the process, and I will, document whatever methodology I end up using as I do it. I also may start doing a little covering because I'm kind of bored at the moment with building, and I don't necessarily feel like, cutting and gluing at the moment. So I may amuse myself and start doing the color scheme on the outer wings, which are complete. I don't know if I showed this already. You will notice that there are two holes here and here, and those are for some connecting pins, because you have your main center carbon spar joiner that is going to provide the structural strength, but to prevent rotation, there's a pin that is going to go in each one of these holes and get glued in place. Now you need to make these for yourself. Take some of the leftover leading edge wing dowel. That's not it, that's bamboo stick. Take a piece of this, and what I did was I took my sanding block and just kind of, worked away at about a 40-degree angle or so, varying the angle until I got a nice little round point like this. Doesn't have to be sharp, it's just to help guide it into place. And then I trimmed it at about a 1/2 inch length, and then I did the sanding again until I got another nice round point and cut it to a 1/2 inch, and I did that until I had 4 of them, 2 for each wing. I'm not sure if I'm going to glue them into the inner or the outer. It doesn't matter really. They are going to function identically regardless of which side they're on. Sorry, the work area is getting a little messy at the moment, a little clutter. So anyway, I guess that's that for now. I hope you enjoyed this video. Please click like and please subscribe to my channel. If you click the bell icon, you'll receive notifications every time I launch a new video. Thank you for watching.